Hi and welcome to the videos for section 10.4. This is the first of 3 videos. Now if you look at the timestamps, you're going to see these are a little bit longer than the typical videos. I normally like to keep them around 10 to 15 minutes for you guys. Some of these might run a little bit longer. Reason being is this section, so section 10.4, is what's known as Algebra of Matrices. So I wanted to break these videos down so that each video kind of contained similar information to the whole video. So again, I didn't want to break it into a bunch and then you had to go searching all over the place if you needed to go back and reference a specific topic. So the first video in here that we're going to look at, the first thing we'll look at is what's known as equality of matrices. So as the name implies, the matrices are equal, meaning the matrices A and B are equal if and only if, so that's our shorthand notation there, they have the same dimension M by N, so remember we talked about rows and columns, that's the dimension, and identical entries. So, for example, i.e., if A is 1, 2, 3, 4, 5, 6, and B is 1, 2, 3, 4, 5, 6. Obviously, they are the same matrix. They're both 2 by 3 with the same values in the same position. That one is equal. However, if I have A is 1, 2, 3, 4, 5, 6, and B is 1, 2, 3, 4, 5, 6, these are not equal. So yes, they have the same numbers in the matrix, but this one is what? This is a 2 by 3 matrix. This is a 3 by 2. So they have to have the same dimension and the same entries in the same position. So that's what we talk about when we talk about equality of matrices. Now our algebra. We have some difference and scalar. So that's a multiple of it. So definition, let A and B be matrices of same dimension M by N, and let C be any real number. So we have the following. The sum A plus B is the matrix obtained by adding the corresponding entries of A and B. So, if I go back to here, if I wanted to add these two first, are they the same dimension? Well, this is 2 by 3, this is 2 by 3, that's fine. So A plus B is also going to be a 2 by 3 matrix. So all I'm doing is adding the corresponding entries. 1 plus 1, 2. 2 plus 2, 4, and so forth. You're just adding the corresponding entries. That's why the dimensions have to be the same. I couldn't add these two because I have 1 plus 1 is 1, 2 plus 4 is 6, but now what am I supposed to do with the 3? There's nothing to add it to. Similarly with subtraction, so the difference A minus B, and so the order matters in this case. A plus B, doesn't matter which one I add, but if I have A minus B, I have to do 1 minus 1, 2 minus 2. If it was B minus A, I'd have to go the other way. But otherwise it's the same. The difference is the matrix obtained by subtracting the corresponding entries. And then third, the scalar product C times some matrix A is the M by N matrix obtained Yep, and all these two, the sum is the M by N matrix obtained, is the M by N matrix obtained. So whatever dimension you start with, that's what you'll end up with. Same with scalar product. Product, the matrix obtained by multiplying each entry by that value C. So let's look at some examples of doing all this algebra of matrices. So let's say A is equal to the matrix 2, 0, 7, negative 3, 5, negative 1/2. B is the matrix 1, negative 3, 2, 0, 1, 2. C is the matrix 7, negative 3, 0, 0, 1, 5. And D is 6, 0, negative 6, 8, 1, 9. So we have four matrices here, A through D. First thing we want to know, what's A plus B? So first I got to ask, are they the same dimension? Well, this one's 3 by 2, 3 by 2, 2 by 3, 2 by 3. Remember, it's always rows and columns. So 3 rows, 2 columns. So because they're both 3 by 2, that's fine. So the matrix I'm going to get is also 3 by 2, and it's just the sum of all the pieces. So 2 plus 1, 0 minus 3, 7 plus 2, negative 3 plus 0, 5 plus 1, negative half plus 2. So that means I have 3, negative 3, 9, negative 3, 6, and 2 minus a half is 1 1/2, which is 3/2. So that's the sum of A plus B. How about C minus D? So are they the same dimension? 2 by 3? Yes, they are. So I'm going to subtract the values of C minus the values of D. So go ahead and try that. Hit pause if you want. Work it out. Hit play. See if you got the right answer. All right, so we get what here? 7 minus 6 is 1. I'll write it out like I did this previous one for now. So we have 7 minus 6, negative 3 minus 0, 0 minus a negative 6. As I always tell you guys, if we're dealing with subtraction and if we have any negative numbers, please be careful with your signs. Here's another case where that's true. So now the second row is 0 minus 8, 1 minus 1, 5 minus 9. So this gives us what? 7 minus 6 is 1. Negative 3 minus 0, negative 3. 0 minus a negative 6 is 0 plus 6, which is 6. 0 minus 8, negative 8. 1 minus 1, 0. 5 minus 9, negative 4. So that's what you should have gotten there. I'm going to erase this, so hopefully by this point you have it written down and can refer back to it. All right, number 3. I want to do A plus C. So let's check. A is 3 by 2. C, 2 by 3. They're not the same dimension, so this means what? This cannot be done. There aren't the right elements in the right position in order to add them together, so this can't be done. We can't add A plus C. They have to be the same dimension. And lastly, what if we have 5A? So that means I am multiplying every single entry of A by 5. It's a scalar product. So here's my A. The solution is going to be to multiply everything by 5. So 2 times 5, 10. 0 times 5, 0. 7 times 5, 35. Now the second column. Negative 3 times 5, negative 15. 5 times 5, 25. Negative half times 5 is negative 5 halves. So there you go. So that's video 1. That's our algebra of matrices, looking at equality, and then looking at the 3 basic arithmetic functions, which is addition of matrices, subtraction of matrices, and then multiplying by a scalar. So come on back and we'll look at video 2.